One of the things we can do with solutions is we can change its concentration by just adding more water. So here I have a cup of Kool-Aid and it's fairly concentrated, and I can add more water to it. Okay, so now what am I doing? I'm diluting it. You can see it's even getting lighter. And what's interesting about this is that the number of particles in this cup hasn't changed, but the molarity has. Did the molarity go up or down? So this is diluting it, so my concentration is lower, so my molarity decreases. So how can I determine what this new molarity is? Well, there's something called the dilution formula, and that's our lesson today. So here's just a picture of what happened when we diluted it. We added water to it and it became more dilute. But there's still only 2 moles of particles here. When I add the water, the number of particles don't change. Okay, so I have 10 liters, 20 liters, 30 liters, 2 moles, 2 moles, 2 moles. So what happens to my molarity? It goes from 0.2 to 0.1 to 0.06. I get less concentrated as I add water and more dilute. Okay, so if the number of moles is constant, the number of moles in A equals the number of moles of B, or the number of moles in B equals the number of moles in C. Now, the number of moles, when I rearrange the equation, is moles times liters. So our dilution equation is molarity initial, volume initial, equals molarity final, volume final, because what did I do here? I made moles equal moles. And what that helps us understand is how much more water do I need to add to get a different molarity, and this is called the dilution equation. Now notice I use volume instead of liters here. That's because I have 2 volumes, so the units would cancel out. So if I have milliliters here, if I'm solving for this, it would be in milliliters, or if that's liters, that's liters. So I really don't need to convert here. I just need to remember what units I'm using. Okay, so we are going to use this dilution equation to find different volumes and molarities when water's added or removed. So we could be evaporating water. But what's important to remember is volume final is the final volume. It's not the volume of the water added. Okay, so, and I will show you a problem with that. So what happens in chemistry is we have a stock solution. I have 16 molar hydrochloric acid. That's pretty dangerous. And in the labs we work with 1 molar, so I need to take a little bit of that. I need to dilute it down so it goes from 16 molar to a 1 molar solution that we could work with in our labs. So here's just kind of an example of what we're talking about. So I have hydrochloric acid, I have 500 milliliters of it, that's 5 molar, and I want to make that solution 2.5 molar. So I don't want a 5 molar solution, I want to dilute it down to 2.5. How much water do I need to add to that? Molarity 1, volume 1 equals molarity 2, volume 2. So I start with a 5 molar, 500 milliliters, and I want to make a 2.5 molar solution, so what will be my final volume? Okay, so my final volume is going to be 100 milliliters. That's not what my question asks. My question asks how much water is needed. Okay, so I started with 500 and I'm going to 1,000 milliliters. So I'm going to add 500 milliliters. Okay, so that's how much more water is needed to add to that. If they wanted to know the final volume, it would be 1,000, but they asked how much water is needed to make that solution 2.5 molar. So that's basically the trick. You have to remember, what are they asking for? Are they asking for final volume, or are they asking for water added? Okay, so here I have a 5 liter of a 1 molar solution. 2 liters of water is added. What is the new molarity? Okay, so I'm just diluting it. I'm not changing how much solute's in there, so that's my dilution formula. So we have an initial volume and a final volume. Well, I don't have a final volume. I have 5 liters and 2 liters of water is added. So my final volume is 7 liters. So that's what I have to use in my formula. So I have 1 molar of a 5-liter solution. What's the new molarity with my final volume of 7 liters? I just rearrange that formula and I get a 0.7 molar solution. Okay, so remember what they're asking for and what you're solving for here.